The gravity plane sits at rest in an open body of water or land. As it spreads its wings, helium gas fills collapsible gas bags within its rigid shell. The helium gas causes the plane to become lighter than air, and it slowly begins to lift off. As the gravity plane is vertically lifted off, thrust is provided by compressed air-driven jet engines mounted on the side of the aircraft. The compressed air comes from high-pressure storage tanks. The gravity plane becomes even lighter as the compressed air is discharged and its rate of flying increases. The gravity plane rises to substantial elevation using the principle of buoyancy caused by the greater pull of gravity on the heavier surrounding air than on the lighter helium, which causes lighter than air lift known as aerostatic lift. During the climb to altitude, minimal compressed air, which is the gravity plane's method of storing power, is used for guidance control and to provide onboard electrical power. Once the aircraft has reached pressure height, the maximum altitude that can be reached because the air becomes thinner with height and provides less lift, it can climb no higher. Air from the atmosphere is compressed into the rigid shell of the aircraft to add weight. This is accomplished by using pneumatic motors driven by stored compressed air that powers air compressors. The stored compressed air that drives the pneumatic motors and the new incoming compressed air flow both into the rigid body of the aircraft on the outside of the helium gas bags. Once equilibrium has been reached, only a small amount of compressed air is needed to cause the aircraft to descend. The higher pressure, heavy, compressed air compresses the low pressure helium within the gas bag and occupies space previously occupied by expanded helium, and lift is lost. The gravity plane becomes heavier than air. The aircraft's wings sweep back to reduce wind resistance, and it begins to descend. The gravity plane begins to accelerate due to gravity acceleration caused by the gravitational pull of the Earth, and as its velocity increases, aerodynamic lift is created. The gravity plane has made a transformation from lighter than air to heavier than air, and is now a glider. While gliding downward, the two vertical axis wind turbines located on the top of the main cabin area begin to rotate to produce power. The output shafts of the wind turbines are connected to air compressors, and additional air is compressed into the aircraft. As the aircraft glides at a high glide ratio for long distances, using its long, narrow, high aspect ratio wings for lift, the high-pressure compressed air storage tanks are refilled with compressed air by the wind turbines, storing energy for later use and adding additional weight to the aircraft to make it glide faster. The heavier the aircraft, the faster it will glide. However, the glide ratio remains relatively the same because more velocity also means more aerodynamic lift to offset the additional weight. Gliders have high glide ratios of up to 60 to 1, and aerostatic lift airships can reach altitudes of over 10 miles high. The gravity plane potentially may be able to glide for distances of 400 to 600 miles. As the aircraft reaches a lower altitude, it can again climb to high altitude by discharging excess stored compressed air through the compressed air-driven turbine engines to provide thrust at the same time that it again becomes lighter than air. The process of using one force of gravity, buoyancy, to gain altitude, and another force of gravity, gravity acceleration, to provide gliding flight, can be repeated as many times as desired because energy is stored during the glide downward by the wind turbines that allows the process to be continuously repeated in a cycle. Some of the compressed air produced by the wind turbines during the descent is carried all the way up to pressure height in order to power the pneumatic motors that drive air compressors to bring in new compressed air from the atmosphere to lose lift during the next cycle. Some of the advantages of the new hybrid aircraft are it does not require fuel. Over 80% of the operating costs of conventional air travel. It can deliver people and products directly to the destination. It does not necessarily need an airport. It's safer because there's no fuel to explode and burn. And the aircraft can float in the air, which can prevent a crash landing. That makes it less likely to encounter terrorist activities because there's no fuel to make it a flying bomb. The aircraft is environmentally friendly. No greenhouse gas emissions, no harm to the ozone layer, and no noise pollution. Landing is accomplished by using compressed air to provide downward thrust to set the craft down vertically. But unlike taking off, minimal compressed air is consumed to conserve weight to keep the craft heavier than air. The gravity plane lands with a cargo of compressed air, which is stored power for liftoff thrust and for power to lose lift during the next descent to high altitude. The gravity plane is ready to lift off again at any time.